Hello everybody, today we're going to be talking about the difference between static and dynamic arrays. Some languages like JavaScript and Python don't even have a concept of a static array. You just use dynamic arrays straight out of the box. But it's good to at least know the theory and how they work behind the scenes. You might get asked this in an interview. So in languages that allow static arrays, such as Golang, we can define it something like this. You obviously don't have to worry too much about the syntax. This is just a size 3 array of integers, and I'm putting in the numbers 461. So we can see this as a 461 block, which has a size 3. And in our memory, it would be something like this, 461. And what makes this a static array is we can't just assume that we can just add something at the end of it, say a 5. We can't do this. Because in our RAM, we are just saying that these 3 blocks are what we are taking up, and we have no idea what's in any of these spaces. The 5 could go somewhere further along the line, like here, and then we will be breaking our rule of arrays, which is they have to be contiguous. And the reason our arrays have to be contiguous is because when we try to find any of the elements in the array, we search it by its index. So arrays are indexed starting at 0. Most things in computer programming are, they're 0 indexed. So the first array is actually the 0th index, the second value is the first index, and the third value is the second index. Just something you have to get used to if you're not used to computer programming. But what this means is I could just go to my array, say it was called my array, and search the 0th index. This would obviously return the first one, which is the 4. And if I was to search then the first index, it knows where the start is, so it just has to look at the second one, but it's 0 index, so it's the second. Even if I was to get the last value, which is the 1, this is happening basically immediately. We say this happens in constant time. And in the big O notation, which is a way of talking about how fast things are or how much space they take, but in this case it's how fast they are, it's O of 1, which basically means this happens lightning fast. We'll discuss the big O notation a bit later on. You definitely need to know this for interviews and just general being a good developer, I would say. But we'll discuss this in the next video when I talk about time complexities with arrays. Now we can assume we declared some other variables, so let's just say x equals 4, and then that'll be dumped into the RAM in the next available slot, which is here. We can also say y equals 6, and I'll just throw that here. So in this case, if I wanted to add something on here, like a 7, it'll just go to the next space in the RAM, which is all the way over here, and we have actually 2 arrays. So we have the first array here, which is of size 3, and we have the second array here of size 1. Now when we want to look for the third index value, we'll be searching my array 3, which gives us this, which is a 4, which is not exactly what we were looking for, which is why dynamic arrays exist. Now, I'm not trying to say that there's never a case where you'd use a static array. They are actually a lot more memory efficient. They take up a lot less space. So if memory is something you're really concerned about and you know for a fact there's only ever going to be 3 values in this array, it's better to declare a static array. So next we're going to see how we can solve the issue of not being able to add extra elements at the end of a static array, and this will be called a dynamic array. So I'm just going to do a quick example. Let's say we have a completely empty array, and we add the number 3, so we put a 3. Then we want to add another number. Sure, there's space, we can do that, and we'll add a 4. Once again, we add another number, let's say a 6 this time. And now we reach this point where we want to add something else, let's say a 9. There's no space here. Our array in our RAM only takes up 3 spaces. So what we're going to do is we're going to double the size of the array and copy all these values into the new array with 3 extra spaces. So we can now put our 9 here. So now we go to some other random place in the RAM. It could be absolutely anywhere. Just we don't get to allocate this. The computer will do it for us. And we create our new array. So we'll have a 3, 4, 6, and we'll have 3 empty slots because we're now declaring an array of size 6. So similarly, we bring our values down and we wanted to add a 9 here. So I'm going to say 3, 4, 6, 9. And once again, we can add something, say a 12, say a 15. So these will go in here. And we're once again at the same situation where we want to add something, let's say a 1. And we'll have to do the exact same thing again. We'll take this array here of size 6, I've run out of space to draw it, but just imagine this in your head. There'll be another array of size 12, and all these values here will be copied down to the other array, and we'll find another space in the RAM where we have 12 spaces free and allocate the new array. Now you might be thinking, why didn't I just create an array that was just of size 4 to add this one extra 9 in here? Why did I have to double it and create a size 6 array? And this is basically something to do with math. It's called the power of 2. And every time we run out of space, we basically have to do this whole operation of reallocating somewhere in the RAM, which takes up O of n time. Once again, I'll go through the big O notation in the next video, so don't worry too much about it, but it just imagine it takes up a lot of time. And not only does it take time to allocate space in the array, it also takes time to shift all these values from the original array to the next array. And also, depending on whatever language you're using, it could be garbage collected. We'll also have to delete this original array. So there's all these steps that take place. And we'll see that by doubling it, we know that if there was space here, just adding a value here would just take O of 1 time. It'll be pretty much instant. And we'll find that by doubling it every time, we end up with something called amortized time complexity, which in very simple terms just means the average time will always be O of 1 to add an element to a dynamic array, because this whole doubling thing will be very infrequent. Obviously, because we're looking at very small arrays, you might think I'm doubling it all the time, but imagine we'll have an array of size 20. You have to add another 20 elements before you even do this doubling procedure. So on average, we end up with O of 1 time. In the next video, I'm going to break this down a lot more, but this was just a quick intro into dynamic and static arrays, and I hope it is clear, even though our board is quite a mess right now. So I like to think of a dynamic array as just a static array that then you can double the size of every time you run out of space. I think out of everything in the video, just take in that one point. Every time you run out of space, double it, and I'm sure the interviewers will understand what you're trying to get at. You can go through this again in the future. It did take me a couple of tries to fully understand this topic, so ask any questions you have in the comments as well, and I'll address them as quickly as I can.